Boom, boom. What's up, Obama?
Well, I don't think I'm cooked. I'm not.
What's
I'm
up?
not getting that quiz, bro.
You're cooked, bro, dude. Oh no, what happened, dude?
Well,
What
my teacher was
happened?
and we had a sub, so we never got anything explained,
Okay.
and we have a quiz. So I don't know.
Well, I can explain things to you. Is that okay?
I already did a question. But it's after equity. So
Okay, cool. Yeah, let's get through it then, dude. Yeah, let's do some for Sir Equity. Yeah, that'd be cool. You figure out why I'm like dropping so many frames on this thing. I don't think I am. Whatever. I'll figure it out later. There's something wrong with OBS, as always. My output settings, yeah. FFmpeg, yeah. Keyframe interval, yeah. Whatever. I'll figure it out later. It's like, I see like there's a, like it jumps. It goes like jump. I don't know why.
well, what do you do the work on?
Where do I do the work?
Yeah.
I have like a whiteboard that I pay for.
Can I see? With like a
Yeah.
what? Like a tablet thing?
We don't want to do this. One sec. You mean like, one sec, let me turn this off.
That thing.
This thing. Yeah, this is just a website that I pay for in order to be able to write things.
Oh, that was like a tablet or some shit.
Well, I mean, I have an actual tablet, right? This is what I write on. And then it emulates like what a mouse is over there. Yeah, that's what it does. Yeah, that's pretty cool though. It's aight. Okay, here, let's start off the stream. All right, welcome everyone to Office Hours. My name is Dr. Gold, Savage Education, the stream that helps you with math homework, science homework, all sorts of fun stuff. Happy Tuesday, everyone. Hope you guys are having a good time. My day's been pretty good. What is it? I woke up, I went to the gym, I did some leg day with a friend, and then what else did I do? I taught. Yes, that's right. I was teaching. Earlier. I got to teach after this as well. I got to teach you guys right now. So a lot of teaching today. Tuesday's good. I got interviews Wednesday and Thursday for IXL. I'm still waiting to hear back from Khan Academy. I submitted the thing to them on Friday. They said they needed it by Sunday, so hopefully that comes back. That would be cool. Yeah. Okay, cool. All right, let's see. Let's see what we're going to do. Oh, you know, I wonder if, one sec, what's my stream quality set to? 1080p, 30 FPS. Yeah, that should be fine. Huh. I don't know. All right, whatever. Okay, Equity. Let's go do your question first. Where are they? Got some good ones in here. That was the average of the things. What was this? Oh, I like this one. This is a cool one. So Equity's doing like a math challenge thing. I think he's doing like a competition. And these are like math challenge competition questions. I need my phone to like shut the fuck up, phone. Jesus. People just want to like text me like crazy. Stop. All right, let's see. Equity. Sir Equity. Is Equity here? If Equity's not here, I'll do Obama's. Equity, where you at? Equita. Equity was first. Posted at 211. That's good. Yes, sir. Okay, cool. All right, let's do it. The operation upside down triangle. This is called Nabla, by the way, guys. This little thing. This is called Nabla. You guys, if you get into higher calculus or like physics and whatnot, you will learn what this thing is, and it's pretty cool. Okay. And okay, so they're saying this is an operation similar to like multiplying or whatever, but they're saying when you have something on either side of this inverted triangle called Nabla, that you take 4 times the first thing and you add it to the second thing. Would this be a 9th grade question? I don't know. I mean, maybe. I feel like it's easier than a 9th grade question. I feel like this is like an 8th grade question. But okay. So they say 5 Nabla 2. Then Nabla with 2 again. Okay, that's okay, okay. So, I mean, this is kind of like an order of operations thing. All right, cool. So we have 5 Nabla 2, right? Then times Nabla 2, right? So we got to do both of these things. Let me make sure. What are my filters on this thing? Filters. Oh, I have a render delay on it. Oh, let's take off the render delay. Sorry, maybe that's what's messing this up. Okay, let's see. Let me reset my stats. No, still dropping frames. I wonder why that is. I don't know. We'll figure it out. I don't know why I had a render delay on this. That's kind of silly. Let's delete that one. Don't need that. Yeah, no render delay. Okay, cool. All right. So 5 nabla 2. Remember that a nabla b is equal to 4a plus b. Okay, so we're going to do this thing first. All right. So that's 4 times the thing on the left of the nabla. So that's 4 times 5 plus the second thing, right? The second thing. So that's going to be plus 2. All right. So that's going to get you 20 plus 2. So that's just going to be 22. Okay? And now I still have 22 nabla'd with 2. So now we do the nabla operation again. Which, right, look. I have right thing nabla'd with... Sorry, left thing nabla'd with right thing, right? So that's going to be 4 times the first thing. Yeah, it was this easy. Yeah, that's okay. It's 88 plus the second thing, which is just 2, right? And that gets you 90. Yeah. Not too hard. Yeah, hopefully you kind of see that. Yeah. Yeah, all good. What's up? Is it? Yeah, I can do 13. Let's do 13. Because, yeah, that one didn't take too much time. What's up, Redacted, dude? What's going on, dog?
Yeah, what's good?
What's good? How's your Tuesday, bro? Super Tuesday. Hello,
I
Teacup.
figured out for gift links with a bot.
That's cool. Gift links with the bot? What do you mean gift links? What do you mean gift links with the bot? You're talking about gift links with the bot.
Here, let me give me a second. It's just gonna take a minute because I gotta load up my computer and stuff. Wait,
Okay,
how
cool.
did that turn on? Why is it on Apple TV?
I don't know. I don't own your TV system.
Here we go. Let me run these again.
I don't own your TV system, Redacted. But yeah, maybe try to
Excuse
save
me.
the live. Don't do the live troubleshooting on the stream. Like.
No,
Okay.
we're good. No, we're good. I just gotta do find the server I was doing on. Then we're good. All right.
Okay, cool.
So let me turn on my camera.
Oh, you
Gotta
want
make
to show
sure
me
it's not
something?
facing me.
You want to show something
Here
to
we
me?
go.
What do you want to show to me? Let me see.
Yeah, I got. It is
Let's see.
so bad on this, bro. Oh my gosh. Okay, give me a
What
second.
are you
Let
showing
hop
me
in.
here? I see a black screen of nothing.
Yeah, you're gonna
Redacted.
see that for a minute.
Okay.
You're gonna see that. As
Uh-huh.
you can tell, my Discord's unresponsive.
That's great. I'm glad.
That's
Glad we
because
have
I launched the server,
okay.
had all of the spammed things on it.
Okay.
So now I gotta go into a different test server that I have. Oh, my Discord completely.
What are you showing me here,
Yippee!
Redacted? Oh,
No,
whatever.
I'm just gonna use my phone and show you.
Okay. Here, let me finish Equity's question real quick,
I
and then you
can't
can
show
show
my
me.
screen. I don't have my
It's
face.
okay. It's all right. Yeah, I don't know. Yeah, Redact is trying to show me something. It's okay. All right. Figure 1 shows an arrangement of 3 lines with 1 intersection point. Figure 2 shows an arrangement of 3 lines with 3 intersection points. What is the maximum number of intersection points that can appear in an arrangement of 4 lines? Ooh, that's cool. Well, let's try to draw some stuff. There's probably some like actual way to solve this, but here, let's try this. 1, 2, 3, 4. Right? That's the way for it to only intersect at 1 point. Right? That would be 4 things intersecting at 1 point. Okay.
That's your phone.
What's
In the
up,
first
dude?
figure, it's intersecting.
Well, this is
either
all
2 or
this.
3 times.
No, this is 1 time with 3 lines, and then this is 3 times with 3 lines. But now they're saying now I have 4 lines. How many times can I make them intersect?
4 times.
Well, here 1, 2, 3, 4. We already got 4, but look at this. I could move. I could move this over. Now we got even more, right? 1, 2, 3, 4, 5, 6. Okay, so these are already gone, right? We already know it's not 4 or 5, right? See, 1, 2, 3, 4, 5, 6. So I think what you want to do is you want to take out the places that there are multiple intersections, which we already have. We've already done that.
Awesome, funny. We're learning about like intersecting lines right now, so
That's cool.
like this. Like,
Well,
not
lines.
this
So
advanced, but, like,
lines intersect when they're not parallel, right? So you need to make them all like not parallel. You got 6 max. I think I may have got 6 max. 1, 2, 3, 4, 5. I just curious. Like let's move this, right? Does that change the amount? No. Let's see. This goes intersects with 1, with 2. You know how to think of it. Okay, here we go. Each line can intersect with 3 other lines, right? Because there's 4 lines. So this line, for instance, like let's look at this line, right? This line intersects with this one. It intersects with this one. It intersects with this one. Cool. That's where we get 3 from that. All right. So this one's done. Let's try to have this one intersect with 3 lines. It does, right? Look, we got 1, we got 2, we got 3. Cool. Right? 1, 2, 3. Oh, but there's a duplicate. Oh, but there's a duplicate. There's a duplicate, right? So this intersecting with this one is double counting this one intersecting with this one. Ah, okay. Okay, so then this one can intersect with 3, but it's already been counted for 2 of them, right? So that's why this only gives you 1 unique solution. And then this one can intersect with 3, but we've already counted it being intersecting with the other 3. So it's actually, it's 7. So this is what it is. It's 3 plus 2 plus, oh wait, maybe it's 6. Sorry. My bad. Yeah, 1, 2, 3, 4, 5, 6. I agree, it's 6. Do you get the math there, Equity, why it is? Like when I'm looking at one line, there are 3 other lines you can intersect with, right? So here, let's label the lines like this. Let's say like 4, and then let's see that, right? That can intersect with 3, 2, and 1, right? Then we go to line 3. Line 3 can only uniquely intersect with with 2 and 4, right? Because sorry, with 2 and 1, because 3 has already intersected with 4. Okay. Then we get to line number 2. Line number 2 can only uniquely intersect with 1. Yeah, this is mathematically how you do it. And then line 1 can't uniquely intersect with anything, right? Because it's already done it with 2, it's already done it with 3, it's already done it with 4. So that's why you get 3 plus 2 plus 1. Yeah, that's 6. Cool. I like that. That's a cool solution. Nice. Yeah, I think that's the way to do it, Equity. That's how I would do it. Equita. If you have time, will you do the rest? We did do the rest. Didn't we do the rest? We did the other one yesterday. We did 14. We did 14 yesterday. And I just did 10 as well.
I got it. Here we go.
Okay, what do you want to show me? All right, what do you want to show me, dude? All right, what do you want to show me?
Spamming. I have it spamming.
Why are you spamming things in someone's Discord? Don't do that.
This is mine. Don't worry.
Okay, but why are you? Why this is gonna get you blocked by Discord, dude? Why you want to spam things in other people's Discord?
It will not get me blocked because it's run by a bot.
Okay. Well, the bot's
And
gonna get banned.
again.
And your Discord's crashing, dude. Yeah.
All right, so I would show you. Give me a second. You're just gonna have to be a bit patient.
Well, I have to redact it. I have to stream and help kids with homework questions, so I can't be too patient. You can show me this after the stream if you want. That's totally cool. You can show me afterwards. Okay, Obama, let's go up, dude. What's up, my guy? Oh wow, look at this. Simplify, dude. What's this like beautiful artwork they have for you, bro? I love this. Obama, what is this, dog? Look how beautiful this is.
What?
Look how beautiful this is, dude. I love this font, dude. It's very pretty. Very pretty font.
It's lame.
Yeah, it's kind of lame. Okay, you want to simplify this? Wait, going shopping, singing, cooking, playing. Dude, what the fuck is this?
It was like a whole fucking puzzle, right? In class.
Like, what is Cardi B? Oh, bro, I hate this shit, dude. I know what you're talking about. Where like the answer like pulls out a word, and the answer pulls out a word, and then it makes a sentence.
It was a whole sentence. I kind of just used context clues for half of them.
Bro, this is the stuff I get kind of like, I'm like, ugh, you know, because they're trying to make like math is fun. And I'm like, no. It's lame. Like, y'all think this is lame, right? You don't think this is cool, do you?
No.
Nah, right?
I mean, it's better than having to hear the teacher for hours, but
Yeah. Yeah, I guess. But it's one of these things where, again, they're trying to, like, make learning fun, but I have this whole belief of, not everything you do in life is going to be fun, right? Do you think it's fun for me to go grocery shopping? I mean, sometimes it is, but, but doing things sometimes aren't fun, but you have to kind of, like, train your brain to be like, I have to do these things anyways. So math is one of those things sometimes where it's not exactly fun, but there's a reward afterwards if you do well in it. So that's what we're doing. Okay.
and it's in the bottom one.
And it's in the bottom one, he says? What?
Yeah, the bottom one.
Oh, yeah, with burn. Yeah, whatever. Okay. All right, let's try to do this. Okay, cosine cubed of theta plus sine squared theta cosine of theta all over cotangent of theta. Okay? How can we simplify this?
Divide the cosine on top.
You want to factor out the
like-
cosine.
Yeah,
I'd
yeah,
factor
that's
out a
what I mean.
cosine. There's a cosine here and a cosine here, right? So I can factor out a cosine of theta. Okay, then what's left? What's inside
Cosine
the factor?
squared plus sine
Good.
squared.
Close. Yes, actually, sorry, you're right. Sorry, because this cosine is attached to this one. Yeah, cosine squared plus sine squared. Very good. And this is over cotangent of theta. Okay, what is cosine squared plus sine squared?
1.
Yes, this is 1. You always need to know that one. Okay, cool. All right, so now I have cosine of theta over cotangent of theta. All right. What is cotangent?
Cosine over sine.
Good. So this is cosine of theta over cosine of theta over sine of theta. What happens
And
when I
keep
divide?
change flip,
Keep, change, flip.
Right?
Nice.
Keep, change, flip. Yep. Keep,
Yep.
change,
Cos-
flip.
Cosine over 1 and then
No.
sine times cosine, right?
Yeah, cosine over 1, sine times cosine. You see how these cancel?
Yeah.
Goodbye. And now we're just left with sine theta, which is this answer. Ice skating. That's cool.
I understand the bottom. Like, I don't know where the two, like, I swear I never learned that.
This one? What, this?
Yeah.
Okay, well, let's try
I
it
don't
out.
get it.
Uh,
Yo,
Who the fuck? Who the fuck is Kentanji Brown Jackson? Who's this? I
don't
only
know.
know like 3 of these names. I know Timothy Chalamet. I know Cardi. I know this. I don't know who Amanda Gorman is or Kentanji Brown Jackson. Who's that? Is that a cool person? They have a cool ass name,
Mm.
dude. I would love to be called Kentanji. That's super dope. Okay. 2 cosecant of theta minus 2 cosine squared of theta cosecant of theta. Okay. Do you see something I can pull out of both of these things?
Cosecant?
More than that, you can pull out a 2 as well. Do you see how there's a 2 on it as well?
Yeah.
You can pull out 2 cosecant of theta. So that, what does this become now? What's left here?
Cosecant, right? I think.
Well, no. So 2 cosecant of theta times what gets me what my original thing was?
1.
1. This is just 1, dude, right?
Mhm.
Minus, what's left here? What does this turn into?
2 cosine squared.
Bro, no. Look. It's we
What
already
do you
pulled we pulled the 2 out, dog. We pulled the 2 out as well.
Oh, cosine squared then?
There you go. Thank you. Cosine squared theta. Okay. Yeah, important. Yeah, you could have, like, whatever, pulled out the cosecant, and then you would have left a 2 here, and you would have left a 2 here, right? Do you see that? But if you see
Yeah.
something in all of them, pull it out as well. It'll make life easier. Okay. Do you know what 1 minus cosine squared theta is?
Sine squared?
This comes from, right? Sine squared plus cosine squared is equal to 1. So if I move this one over, right? Then that's 1 minus. And you see how 1 minus is sine squared? That's another one you want to be able to like see and whatnot. Yeah, okay, cool. So this just goes away, right? And now this is just going to be sine squared theta. Okay, what's cosecant of theta?
1 over sine.
Good. So you get 2 over sine of theta times sine squared theta. What's sine squared theta over sine of theta?
Sine?
Good. So your final answer is 2 sine of theta, which is who? Which person is that?
Timothy.
Timothy Chalamet! Yeah, nice dude.
That's dope.
So, I actually don't want that on my quiz. No way. I'll do anything but that.
Yeah, honestly, it's a pretty lame ass question, but yes, cool. Does
For
that make more
real?
sense, Obama? Does it make more sense, dog? Yeah.
I mean, the first part, I just got kind of confused with the 2. I didn't know what we were supposed to do with it. I thought you could only cancel out the cosecant, not the 2 also.
No, you can pull anything out. If anything is in all the factors, you can pull it out.
Oh.
You know what
Okay.
I'm saying? Like,
Yeah.
if I had like 5 minus 5 cosine squared theta. Let's say this is like 5, I don't know, sine theta minus 5 cosine squared sine theta, right? You identify that the common thing in them is a 5 and a sine theta, a 5 and a sine theta. So I can pull that whole thing out of both. So this is 5 sine theta, and then it's 1 minus cosine squared theta. If you're ever confused what this is, just try distributing it back and just make sure you get the same thing, right? If I distribute it back, I get 5 sine theta, right? Minus 5 sine theta cosine squared theta, which, look, is the same fucking shit as this, right?
Nice.
That's
That's the
the trick.
last part though. I'm gonna have to remind myself about that.
No, I got you, bro. Here, what is it, this? Here, I'll send this one to you.
Did you put the green part, like the last thing you explained? The 5
Yes, I can do that as well. I'll give you all of it. I'll give you all of it. All of it. I have all this. There you go.
Thank you.
Nice. You're welcome, dude. Yeah, always. Yeah, if your teacher's not teaching you shit, Obama, like come to the stream. Let me help you, dude. I got you.
All right.
Nice.
Nice.
Okay, we're rocking and rolling today. I drank a lot of caffeine today. I'm like fucking wired. All right. Yes, Equity. We'll probably have time to do some of the other ones. You're not the only one. You're too young for coffee, redacted, dude. Chill, dog.
Josh.
He's like, hush. All right, let's help Miguel out. Miguel has this. Okay, in a figure, an elastic band is used to hold 7 pencils of diameter 8 meters. This thing looks like a chain gun or something, bro. What? Like, do you guys know what I'm talking about? Like, what is it? The GRU gun on the Warthog? This thing is pretty cool. No, that's GRU. No, what is it? Sorry, the A10 Warthog gun. This gun, yeah, or the GAU Avenger. Yeah, this thing is super sweet, man. Yeah, that's what this kind of looks like. You're trying to like fit like 8 pencils in something. Yeah. Okay. Paste it back in. I got rid of it. Okay. What is the length of the band in this position? Ooh. Huh. Do I assume this is a hexagon? I mean, the issue is that these are not sharp points. This is actually a little confusing because these are not sharp points. And it kind of like it wraps around. I wonder like how exact they want you to get here. But okay. I gotta think angle wise what this does. Okay. So we have to have a total of 360 degrees around everything, right? I wonder how exact they want you to get. Because I could, for instance, I could find this arc length is what I could do. This is an angle. This is an arc length I could find. Right, because this is some theta. I guess this would be, I'm trying to see what this is. 1, 2, 3, 4, 5, 6. I'm guessing that's 120 degrees. Right? It's a weird ass shape, dude. What does this actually become? Because then, yeah, and then we also got, what is it, like here to here? And then, yeah, right, here to here. And then I got to figure out this distance as well. Ew. I thought it was vectors. I mean, you probably could do this with vectors, right? I'm just wondering, you know, am I allowed to just approximate this as this? I mean, if I wanted to just approximate it this way, right? This is not too hard of a question to do. But it depends how exact they want you to get. One second, let me ping the kid who asked this question. Like, I need to know, like, Miguela, where you at, dude? And while I'm at it, I'm gonna look this question up real quick. In the figure, good old Chegg.
What type of question is this again?
What's up? Oh, Miguela's here. What's up, Miguela? Yeah, get up here, dude. An elastic band. It's like a geometry question is what it is. Is used to hold 7 pencils.
Alright, I don't have that big of a brain then.
It's okay. Use 7 pencils of, and I guess it's of diameter 8 meters. Miguel, what level of math is this? Like, how are you in calculus? Are you in geometry? That will let me know how exact I need to get with it. This actually doesn't have it. Okay, well, if the diameters are 8 meters, right, then I know this whole distance right here. Oh, interesting. I don't really actually know, do I? Oh, okay. This is a, what is this? 1, 2, 3, 4, 5, 6. This is a hexagon. Okay, so we need an equation for the perimeter of a hexagon. Yeah, I know it's 6 times A, but how do I get A? Yeah, perimeter of a hexagon. This is, yeah, I want it from the sides, though. Perimeter of a hexagon, I don't know, from radius, maybe? Maybe that'll do it. Yes, I agree all the internal angles are 120 degrees. Okay, there we go. This is what I want to know. Yes. Okay. Tricky question. Okay. So the distance to the edge, let's say from here, right, to here, okay? I know that's going to be, it is really good to have some basic stuff in your head to check work in Calc 1. I agree, dude. Really definitely is. Other volume of sphere. Yeah, these are all critical things you have to know. This is like kind of one of the weirder ones, right? So if I want to get this side length here, right? So I know that this is going to have a total angle, right? Eventually of 360 degrees, right? As we go all the way around in the circle, we got to go 360 degrees. We're dividing it into 6 equal parts. So I know that this is going to be 60 degrees, okay? And that this side is equal to this side, right? So now I can figure out what this is, right? By doing some math. Okay, so if this is 60 degrees and I need the total to be 180 degrees, okay, and these sides are equal, that means this side equals this side. Okay, that means this is 60 degrees, which means this is 60 degrees. Oh, interesting. So this is an equilateral triangle at this point, right? So whatever this side is also the side of this. It makes sense, Miguela. So from here to here is a diameter, and then this is half of a diameter. So it's 1.5 diameters is equal to the side length. The diameter is 8 millimeters, right? So 1.5 times 8 is going to get you 12 millimeters for a side, right? Which then we multiply by 6, right? There's 6 sides. 1, 2, 3, 4, 5, 6. That should give you 72 millimeters. Do we know if that's right, Miguela? Is that the answer for it? Is 72 millimeters is correct? Yeah, that's an interesting question because I technically, yeah, no, I can send it to you for sure. Yeah, for sure. Yeah, I can send you a screenshot. Yeah, you don't really need this. This we don't need. Get rid of that. But But this part is kind of what you need. Yeah. So yeah, it's because it's an equilateral triangle. And here, let me make this a little bit more clear. 60 degrees, right? This is equal to this, which means this must be 60 degrees, which means this must be 60 degrees, which means this is going to be the same. And then, yes, you have one diameter, and then you have 0.5 of a diameter, or the radius. Yeah. Cool. Yeah, 1.5 of 8, and yeah, 12 meters is a side times 6 sides. So this is per side. Yeah, you get 72. Nice.
Well done. Well done.
Good job, Miguela. Nice. Oh, I don't know why it sent so much stuff up top there. But yeah, that's the screenshot. Yeah, cool. Nice. All right, let's see. Let's try another one. Taco Cat, let me help out Patty real quick because I haven't helped Patty in a while. What's up, Patty? You want to come to the stage? Come say hi. What's up, dude?
What up?
What up, dude? What up, fam? What are we doing? Looks like areas of shit, yeah? Oh, volumes
yeah,
of revolution.
something like that, but it's not just taking the area of it, it's also like flipping it across
Yes,
the
rotations of
axis,
revolutions.
and then yeah, it's like basically volume and
Okay.
area, I guess.
Okay.
So in this I think these are all area problems, yeah, or volume.
Okay. You need help with all of them?
Just like just
Or, like, showing the
explaining,
concept
like,
of it?
the equation of
Yeah,
how
yeah,
to
yeah.
find it, because
Yeah, for sure.
I understand that it's pi integral whatever your interval is,
Mm-hmm.
and then
But then it's like
R-
whether it's dx or dy or
Rx
something.
capital Rx squared minus little r y x squared, but like sometimes I don't understand how to get r of x and little
For
r
sure.
of x.
Let me get that for you. Okay, here. Let's.
So I mean, my work is there, but like I don't know, today in class it just wasn't clicking for me. So
That's okay. Okay, volume of revolution. Given around a different axis of revolution. Okay, all right. Which is the axis the red one? Yeah, right. Yeah.
That's the one you're flipping it over. Yeah.
Yeah, good. So here, like, you're rotating it about this is what you're doing, right?
Mhm.
Okay.
Yeah.
So I always like to say, okay, whatever the axis of rotation is. So in this case, it's like y, right, is equal to 0.
Mhm.
That means your integral is going to be dx. Okay?
Yeah.
Because you're going to add up a bunch of different things like in this regard, okay?
Mhm.
So this one is going to be, yeah, cool. Integral, and then just right off the bat when I see these, like, here, I'll do them above it, I guess is what I'll do to make a little bit of space. I say, okay, cool, integral dx. Once I know it's dx, now I just need to say, okay, what x to what x are we going, right? Here I'm going from 0 to 2, right? 0 to 2, cool. And then there's always a pi. And then outside I need to think about, okay, but what is the radius of this thing as I go this way, right? And what I see is that the radius, right, this point right here as we're going, right? The radius refers to this.
Yeah.
Do you see that? Okay.
So that's like your Rx, right?
That is. Okay. What is that? Like, what is that distance? What is that? In terms of the function.
Well, it's what the parent function is, so it's x squared, right?
Well, it's so here's how I want you to think about it. It's the y value, right? The y value
Mhm.
of this function. Okay?
Okay.
This function I think is what? Y equals x squared?
Yes.
Okay. That's what this is?
And then the line is obviously x equals 2.
Yeah. Well, that's what told us we were going from 0 to 2, right? That told us the 0 to
Yeah.
2 shit. Yeah.
Mhm.
Okay. Yeah. So it's the y value of this function. And then when you look at your integral here, right? Do you see how it's dx? That means I need
So
my
all in
radius
terms
to
of
also be in terms of x. Yeah, exactly. Right?
Yes.
So, in order to describe the y value of this function, right? In terms of x, that's just x squared. Okay?
Yeah.
So I'm just say cool, x squared, cool, integral done. All right? Let's make things harder. Okay? Now we're revolving it around here. Okay? So it's going this way. Okay, this kind of sucks.
Yeah, this is like there's like disk method and washer method. Washer method is like the much harder one.
Well,
to
the washer
understand.
method is just two disks being subtracted from each other. That's all it is.
Mm-hmm.
That's all I like to think. It's nothing. It's not too bad. Okay. So in order to get this volume, let's say we want this, right? I need the area of the big disk minus the area of the small disk, because this is going to kind of make like a donut. Do you see that? Like if we rotate around here, right? Like this right here is going to be like the negative space, right? This is like negative space. There's like nothing here. We don't want to include that area, okay? So good.
Yeah.
So again, it's always just r outer squared minus r inner squared. And then again, since we're going this way, I already know it's dx. So now I need to describe what the radius is of the outer thing compared to what the radius is of the inner thing. Okay. So as we go from 0 to 2, right? What is the radius of the outer part of the donut?
Is it the y values, whatever the y value is?
So it's this distance, right? Do you see as I move
Yeah.
as I move, right? As I
Yeah,
move.
the distance of y from the x-axis.
Well, it's not the
So is
distance
it
of y.
So it's 4, right?
It's
'Cause
always
the
4.
line is at y equals 4.
Good. It's always 4. Yeah. Do you see how, like, for the outer one, my outer one is always located 4 away. Okay?
Mm-hmm.
So this I can just replace with 4 squared, right?
Mm-hmm.
The inner one is trickier, right? Okay, because the inner one refers to this distance, right? This is the inner radius.
Yeah.
Okay? So now I need to think, okay, let's say I'm at some random ass position like right here, right? How do I describe how far this is? How do I describe how far this is?
However far away it is from 4, I
Good.
guess.
Good. Okay. So let's think. I know that this total distance right here is 4.
Is 4.
Okay.
So it would be...
And then what is this
so
distance?
so it's in terms of x, right?
Mm-hmm.
So, and the function is x squared.
Mm-hmm.
So it's... Would it be 4 minus x squared?
Yes. So remember, this is x squared, right? The value, the y position of this thing is x squared.
Mm-hmm.
So then this must be 4 minus x squared,
Okay.
right, in order to get this, okay? So this becomes 4
Yeah.
squared minus
Okay.
4 minus x squared squared
Mm-hmm.
dx.
And
Okay.
then we get whatever value is.
Expand it out. It's a big fucking messy integral. Who cares, right?
Yeah, I just
Cool.
plug it into my calculator.
Yes. Very good. Okay.
And then
Okay.
that one, it's just another, it's the same thing, just like now it's 5. So it's literally just 1 further away.
It's 5, yes. But then this one's like weird, right? Because R inner. Yeah, it's 5 minus. Okay, that's okay. Yeah, that's fine. Yeah, that doesn't change anything.
Yeah. Okay, and then like the harder, I feel like it's much
This one?
harder to think about it in terms of y. Yeah,
Yes,
because you have
you're-
to like make everything in terms of y. So the integral is in terms of y and the inside.
Yeah,
of it is
yeah.
also
All
in
good,
terms
all
of
good,
y.
all good, all good. Okay, so we're rotating around this direction, right? Which means I'm integrating stuff down this way, which you're right. That's why it's dy, okay? And yes, we're going from 0 to 4 in terms of y, right?
Mm-hmm.
Okay, another thing, right? This is another classic like negative space one, right? So I had this is the whatever they call it, the fucking washer method, right? Because you have to get this, right? This is going to be your R outer, right?
Yeah.
And then this, maybe this helps, like just write out what like R outer is and write out what R inner is. Okay. You can see that R outer, right, as I travel in this direction, will always be what?
2.
2. Good. So this is just 2 squared minus. Okay. Now we got to think about what R inner is, right? So R inner refers to this distance, okay? Which is what along this function? What is that?
Would it just be
What value of this function is it? Is it the x value of the function or the y value of the function?
the y value?
No. It's the x. So the distance
Oh,
from
yeah,
here to
from
here
there it is, yeah.
is what the x value of this function is, okay? So we have y is equal to x squared, right? It's whatever the x value is. But I need the
Yeah,
x
so we
value
have
in
to-
terms of y.
Yeah, so you have to manipulate it, square both sides, right?
Square root both sides. Yeah, so x is equal to the square root of y. Technically, it's plus or minus because there's another one here, but who cares? Right? I only care about the positive one.
Yeah.
Okay. So yeah, so your R inner here is just now, it's the x value, which is the square root of y. So this is the square root of y squared.
Squared.
Yes. See?
Okay.
Not so bad. All right, it's going to get worse. It gets worse before it gets worse.
Unfortunately.
Unfortunately. Okay. This is going to be kind of the same integral. Okay, we just got to figure out R inner and R outer, right? Okay.
Hmm.
So now we're rotating around here. So this isn't an R inner or an R outer, right? Because I don't have a negative space. There's not a core that I don't have, right? I have everything.
Hmm.
Okay. So this is just R. And this is where we got to kind of like draw, right? So R refers to this distance, right? This is R. Okay. Which is kind of weird. So how do I describe what this distance is based on like where I am along this function?
I guess I'm assuming it's 2 minus square root of y.
Yeah, good. So this whole thing is 2, right? Remember that this distance right here, right? That's the square root of y, right? It's the x position of the function, right?
Yeah.
So r is going to be 2 minus the square root of y, right? So good. So this is just 2 minus the square root of y squared. Yeah?
Okay.
These are good examples. I like these questions. These are good ones, actually, honestly. I should make a TikTok on this. Okay.
Yeah. Okay, so now we do have an
Now you do have a negative space. You got a negative space, yeah. Okay.
Yeah.
So good. 0 to 4 pi, whatever. We got to figure out R outer and R inner. What's R outer?
just 2.
No, that's R inner, right?
Oh, that's inner.
Right? This is the inside, right? So R
Okay,
inner.
So the outer is a 4. Oh, wait.
You got to draw it, right? So this is R outer, right?
Yeah. So
Okay.
is it 4 minus square root of y?
Yes. It is. It is. Yeah, good. Yeah, right? Because this right here, right? Yeah, that's square root of y, right? So it's
it comes like the number, like your interval comes before your like function basically, because you're subtracting the function away from whatever your distance is. Is that like a good way to think about it?
yeah, that's a good way to think about it. Yeah, because you know this whole thing here is honestly I have to draw the pictures for me to really see it. I got to draw the pictures. Oh, yo, what's up, Don? Thanks for the raid, bro. Big shout out to Dawn. We love Dawn, dude. Yes, we're doing Volumes of Revolutions. And how they try to fuck you all the time, like putting the axis for rotation in different points. Can I shout you out, Dawn? Can I do that? Is it that? Is that how that works? No. What is it? Is it has exclamation shout out? Ugh. No. Okay. Whatever. There's some way to do shout outs on. One sec. I want to figure out how to do this. One sec. Shout outs on Twitch, because I've seen people do it to me. Yeah. Oh, / shout out. Oh, that's annoying, dude. What? / shout out. Dawn. There we go, Dawn. Thank you, dude. Cool. Yeah. But okay, yeah. So that's the trick. I honestly like when I see these questions, Patty. I gotta draw the picture out, and I gotta be like, okay, cool. You know, this shit is 4. This is square root of y, so it's 4 minus the square root of y. Yeah.
Mm-hmm.
Cool. Oh, okay.
Gotcha.
Now we get super hard. Uh-oh.
Yeah, these are like
Uh-oh.
really weird.
Uh-oh.
Okay, yeah. So I know that we need to get the
Oh,
point
God.
intersection.
Oh, we're gonna have to
so
split
I
this
already
bitch.
Found that in the calculator.
Okay. Yeah, you found
our
out where they
teacher at the end
intersect.
of class mentioned that we have to split it, but like everybody was already at the door, so nobody like actually listened.
Okay. That's unfortunate. Okay, whatever. I'll do this. This is a really blurry ass picture, but I think I can get it.
My
Zoom
mom's
enhance.
lighting's
Zoom
a little
enhance.
off.
Zoom enhance, dude. Okay. No, not this. All right. Yeah, because what changes here is like the R outer is going to change based on where you are in terms of X. Okay?
Mhm.
So if we're revolving it right around this axis, the tricky part of this is that from here to here, right, this function is our outer. But then from here to here, this function is our outer. And they're two different things.
Yeah, they're different.
So what is that? E to the x minus 1, and then...
6 minus 2x.
Okay, so yeah, good. So yeah, find the intersection point, right? E to the x minus 1. You set them just equal to each other, right? E to the x minus 1 and 6 minus 2x. And this should be able to... You should be able to solve... Do they expect you to use a calculator for this? I don't know if this is analytic.
I don't...
I don't think it's analytic. Yeah, this sucks. Because this is e to the x plus 2x is equal to 7. I don't know how to solve that, like, analytically. You need a calculator for that.
Shit, I don't either.
Yeah, they're not making these easy, Don, right? Yeah, these are tricky. Weren't we doing something like this with you, Don, on one of your streams? I think we were at some point. What's up, PC Lingo? Okay, I'm just going to trust that this is the right value you got. What is it, like 1.42?
I used my calculator, and I did...
Yeah, set them equal to each other.
Intersect, so it should
yes.
be right.
Good. Okay, I believe you. I believe you. Okay, so let's say 1.42 is the intersection point. Okay, cool. All right, again, we're rotating about y equals 0, so that means my integral is going to be dx. Whatever the axis of rotation is, it's the opposite. Okay. But we got to split this into two now. So I'm going to do it's this one plus this one. Okay.
Yeah, and obviously it's like pi on the outside, but
yeah. Okay. Whatever. Yeah. The pies. Whatever. Yeah.
we know that.
Right. So I mean, this is easy, right? So from 0 to 1.42, right? It's going to be, your radius is just going to be the y value of this, right? Which is just e to the x minus 1 squared. And then good. From 1.42 to 3, that's going to be whatever this value of the y value of the function is, right? Which is
2 minus 6, or 6 minus 2x.
6 minus 2x squared. Yeah, nice. Yes. Nice, dude.
Nice.
Okay.
Okay, let's make it harder.
These in chat as well.
I'll yeah, no, here, I'll send you PDFs of all these. Yeah, you'll get PDFs of all these. I actually like this. It looks like really fun and multicolored. Next to the same as box numbers. Yeah, similarly annoyingly. Yeah, come on, e to the x plus 2x plus 7. Easy mental math. No, dude, it's not. This is not easy to do.
What the fuck is this piece of shit?
Anyways, okay, we're gonna try to do this one though. Okay, this is gonna be a little bit harder. All right. Oh man. Okay. Again, same. Let's break this one up. Or here, let me put this on a different page just for clarity. Okay. Okay. Same thing, but now this has to change because now we do have a washer per se, right? Because when I go from here to here, right, this is all negative space that I'm not dealing with. Okay?
Yeah.
Okay, so what's our outer? What is our outer for all of this as we're rotating around this? Yeah, thanks, dude. Thanks for calling.
What is our outer? Okay.
Yeah, what's our outer? That's what I would draw. I would just draw like, what the fuck is our outer?
Visualizing it.
Okay, always just draw.
Outer.
Yeah, our outer. What's that? Because this is like the outer part of my thing.
I guess 6 minus 2x.
No.
Oh wait, no, it's 3.
It's 5.
Fine.
You see how the distance from the axis rotation to here? This is always just 5.
Okay.
You see how? Yeah. Whenever I make my discs, right? This is always the outer border. Yeah.
Okay.
Okay. All right. So this is going to be 5 squared minus. Okay. Now we got to figure out our inner squared, right? So our inner for this one, right, is going to be this distance. Oh, I need a better color. This is fucking hard to see. All right. It's going to be like this distance. Okay. This is our inner. Which is equal to what?
So it's just 5 minus e to the x, whatever.
Yeah, whatever the y value of this function is. Yeah, good. So this will be 5 minus e to the x. What the fuck was this? E to the x minus 1? But okay, but we gotta like put the right parentheses and shit on it. One sec.
Yeah.
So annoying. Okay, so it's 5 minus e to the x minus 1, all of that squared. Cool?
Okay, yeah.
And that should, and it's the same for this one, right? We're just gonna use a different function.
Yeah,
So
so it's 5 squared
Mm-hmm.
minus the, what was it? 6 minus 2x squared.
5 squared minus 6 minus 2x squared.
Nice.
Nice. Then you're done. Okay. All right. All right. Now, ooh, now they're getting really tricky, dude. Ew. Okay. Where is it?
My favorite.
Yeah, this sucks, honestly. Okay. Okay. Let's do these. Copy them in. Nope. Go. Oler, what are you doing? You doing some random math questions for us, dude? Okay. Can I just see by inspection that these intersect at 3? I mean, what was it? It was e to the x minus 1 was equal to 6 minus 2x.
Yep.
Yeah. I think they intersect at 3. It looks like they intersect at 3, right? Let's just assume they intersect at 3.
Should I pull out my calculator and see for sure again?
I mean, I can
I
pull
did
out my
it in
calculator.
class, but-
Yeah, where's my calculator? Where's that? Where's that calculator, dude? Where'd you
Hold
go,
on, is
Wabbit?
it still in here?
One sec. I have my gold one.
It is still in here. Okay. So second calc intersect. I got you.
Okay, you got it. I got the gold one too.
Yeah, it's well the x value is 1.42.
But the y value is 3.
Is 3.15.
Oh, it's not exactly 3. Ooh, they're messing with us, dude.
Yeah,
All right, let me double check that for you, dude.
we don't like that.
I don't like that at all, dude. It's ugly. Okay, yeah. So second calc intersect blah blah blah. Dude, why, bro? What? No. Okay, first of all,
That's
I don't
fucked
get
up.
you. Wait. Do we have the same? I got like 1.21. You got 1.42, right? Oh wait. E to the x minus 1. Did I have the wrong thing in there? Yeah, I forgot the minus 1. My bad. My bad.
Uh-oh.
Uh-oh. I didn't make that
He
mistake.
doesn't
It's
know how to
okay.
use a calculator properly.
It's okay. Smooth brain moment. Yeah, it's okay. 3.15. 3.15. Okay, cool. All right. So this is at 3.15.
Mhm.
All right.
And then
All right. So now, right, we're rotating around the what is it? X equals 0.
mhm.
So that means we got to go dy, right?
Is the integral 0 to 3, right?
Yeah, it was 0 to 3.15
Yeah.
pi. Okay, good. All right. So now I need to know, right, what R outer and R inner is, okay? So R outer is this. R inner is this. Right?
Yep.
Okay. So what is R outer in terms of the function? What part of the function is it? So the x value of the function, the y value of the function?
Well, it's the x value, right?
Good. It's the x value of this function, right? Which I know, right? That's y is equal to 6 minus 2x. So the
Yeah,
x value of
so
this
you gotta,
function,
like,
you got to
simplify
rearrange.
it.
Good. So it's y minus 6 over negative 2. So that's the same thing as 6 minus y over 2. Okay, that's equal
That
to
is
x.
not nice.
It's okay. Okay.
That's alright.
So this is R
I
outer.
just plug it into my calculator anyway, so.
I know. So you can write 6 minus y over 2 squared. Okay, minus, right? And then R inner is the x value of e to the x minus 1.
Yep. So what it would be ln, yeah, y plus 1.
Oh, y plus 1. Okay, cool. All right, done, right? Cool. So now that's ln of y plus 1. All of that squared. These are not nice integrals to do. Like, I don't know how to do
Nope.
the, like, integral of ln squared. Ew, that is so gross. Would not want to do that, dude.
Well, ln,
I wouldn't do that.
like ln x squared is just 1 over x squared. I know that, but like.
Yeah, that one's okay, but the other one's that one sucks. Okay, cool. That's not too bad. All right, last one. This one,
Last one.
same thing. Integral from 0 to 3.14
0.15.
or what?
Yeah.
15 I want to say it's pi, dude. And then that's what is that, dy? Yeah, dy, right? Yeah, okay.
Yep.
Cool. All right. But now R outer is kind of weird, right? R outer
It's
is
the ln function, right?
well, R outer is now this. No, R outer is kind of like what our inner was, right?
Okay. Yeah.
Do
So
you see how this is R outer?
that's yeah. So
Mhm.
it's 3 minus whatever the
Good.
function
Yeah.
is.
That's the important thing. Yeah, is to recognize that like this whole distance here is 3, and so this distance here is like the x coordinate of this function. So good.
Yeah.
Yeah. You're getting the hang of it.
Wait,
so R outer is
for
equal
the
to.
last one, did we take that into account, like the distance?
We didn't need to because the distance was measured from x equals 0. So the
Okay.
distance this function is in x is the distance from the x equals 0 axis.
Oh, okay.
Whenever the axis of rotation like moves
It's,
away
like,
from
off of,
0,
like, that axis, yeah.
it's if it's off of 0, then yeah, you have an offset is what it is. Yeah.
Okay, so 3 minus what was the
What
function?
fuck
ln?
was it, dude?
Is that
s-
ln, right?
Yes, that's the ln one. So ln of y plus 1.
Mm-hmm.
Cool.
Okay,
And then our inner
is what's its face?
6 minus y over 2, right?
Yeah.
Okay. And so then you
And
need to plug that
then
all that
They're
in
both
here.
squared, and you gotta add them together, right?
You can subtract them, right?
Oh, you
It's R
subtract.
outer squared minus R inner squared. Right?
Wait, why do we subtract them? I thought it was add. Oh yeah, it is.
No, because
subtract.
this gets the whole thing, right? And then this gets rid of the negative space.
Okay, yeah.
Cool. That's a good set of questions. Yeah, makes more sense.
Yeah, it definitely does help a little bit.
Yeah,
looking
good.
Over it.
Good.
Today in class, I was just like, I don't know.
You're like,
was
I don't
not
get
in it
this.
today.
No, bro, this is complicated shit. Honestly, it really is.
It really is, yeah.
But I wish I'm gonna
like
make a TikTok video on this because I always explain this. I'm like, just find our outer, find our inner, and then you got to find the distances in terms of the x coordinate or the y coordinate of the functions. That's how it goes.
Yep.
Europe. Okay, cool. Let me dump some screenshots for you. A lot of screenshots. A lot of them. Yeah, well, we did a bunch here. Well, these are good because man, I do need to like go over these myself, and I'm glad to have example questions that teachers are asking because then that helps me to write something that's relevant to what's going on in your class. Yeah, volumes of revolution. That's funny because yeah, I'm teaching another student later tonight who's doing calculus, and yeah, they said I need help with volumes of revolution. It's funny how you all do the same stuff at the same time. Because this student's in LA.
Interesting how shit works.
Yeah, and you're in Chicago, right? It's just like what?
Mm-hmm.
Yeah, this stuff was easy. Yeah, okay, cool. Nice. Okay, there you go. Yo, how's Flipper, dude? How's our boy Philip, dude? Is he right?
He's living his life.
Okay. It happens. People
Yeah,
live the life.
Just, being your average AP Physics C nerd,
Okay. Oh, because
Yeah.
you're not in AP Physics C.
Oh no, I
Oh,
think
okay.
I'd want to kill myself.
It's
No,
not that
I'm in
bad.
AP Biology.
Oh, AP Bio's okay. Yeah, you just like memorize stuff, right, for AP Bio?
Yeah, pretty much. It's not that bad.
It's
We're going
not
over
that bad.
Feedback mechanisms right now.
Okay.
Which isn't
Cool.
bad.
Yeah, feedback. That's like positive feedback, negative feedback.
Yeah, positive, negative, all that stuff.
I always like the cool thing with like a positive feedback loop is if you're on a motorcycle. Have you ever ridden like a dirt bike or a motorcycle?
Yeah.
The throttle on it, you pull back, right? You twist it in order to But here's the problem is that like if you twist it too fast and you wheelie, you end up twisting it even more, which then makes you go even faster. So this is an example of a feedback
yeah, like
loop.
amplifies the feedback. Yeah.
Exactly, it amplifies what's happening. Yeah, so cool. All right, nice. Yeah, if you ever got more questions, dude, like bring them by. Like, let me help you out, dude. Good to talk to you,
Yeah,
man.
I'll come by when I can.
Sick, dude. Nice.
All right. Peace out,
Well,
Dr. Gold.
Peace, dude. All right, GDHWVDJXBA23. very unique username, dog. You want to explain? You want to explain your username to me, please? I don't have a question, but can you make a fish look to the sun with a car is making a flip in the water pool? Bro, what? What? I just had a stroke, dude. Dude, what? What are you saying, dog? Excuse me? Can you translate that back to English for me, please? Yeah. Sorry, maybe English is not your first language. It's okay. I'm just trying to understand, like, what is this? What is this question? What's up, Picholingo? How would Velociraptors DJ? That's a good question. You know what? Actually, I'm curious. Like, let's see what ChatGPT says this. I'm just curious. I have ChatGPT 4. I pay for it. Okay. Let's see. What this? Yeah. Okay. Let's see. Let's. Oh, it's trying to make an image. It's trying to make an image for you here. Oh, your English is not good, lovely sir. It's okay. Speak in your native language, so then I can translate it for you. This is apparently what we would get if we a fish looking upwards to the sun with a car making a flip in a water pool. Here it is. Very epic, yeah, right?
That's dope.
Bro, this is like stupid epic. It's cool. All right, let's help. Josue, what's up? Josue, you want some help? Let's help you out, dog. Yeah, we're not doing this question. Here we go. Okay, cool. All right. Can you hear me on Discord now, Josue, this time? I remember you couldn't hear me on Discord last time. Can you hear me this time? Do I have your volume up? I have your volume up. I can't hear you, but it's okay. Okay. The region in the X-Way. Oh, wow. Yeah, here we go. More volumes of revolutions. More volumes of revolutions. Yup. Okay. All right. Let's draw some graphs. Using shells. Using washers. I don't get why they make you use both methods. You should just get to pick the one you want, which you can always use washers. Like, washers always works. I don't understand, like, isn't the shells thing, is that where, like, we gotta, like, make these things? I don't like these. These suck. Yeah, I like making the washers better. Okay. In the XY plane that is above the x-axis, okay, below the curve, y is equal to the square root of x. Okay, so let's draw that out. So this is kind of this is what, like, y is equal to the square root of x looks like. And between the x values of x equals 1 and x is equal to 4, rotated around the line y equals -3. Ooh, okay. So then they're rotating it around here. Let's make a dotted line. Okay. This is y is equal to -3. And they want to set up a definite integral for the volume of the solid. Okay, Josue, cool. So that's going to be specifically this region here. We're going to take this and we're going to rotate it around. So this is what's going to be called, like, the negative space. Like, you don't want to include this, right? The painting's now going for 3,000. He thinks that car question is a setup. Okay. All right. Here's what I want to do, okay? Like I was showing, so first of all, right, if we're rotating about the y-axis of something, like y equals something, that means my integral needs to be dx, okay? Because we're going to go along here making a bunch of, like, these disks, okay? And what we learned, what's up?
Well, can you hear me now?
I can hear you, Josue. Yeah, what's up, dude? You can hear me?
All right, sweet. Yeah.
All right, good. All right. You let me know, like, parts you understand, parts you don't understand. Okay? So, I don't know if you saw earlier when I was helping Patty out, but it's pretty similar. I'm going to show you kind of the same technique, okay?
All right.
All right. So, I want to know, like, right, what the area of this whole thing is, right, minus the area of this thing. And we're going to denote that by here. I'm going to call this thing our outer, right? And I'm going I'm going to call this our... What's up, Ethan? Good to see you, dude. I'm going to call this our inner, okay?
Okay.
All right, so that's going to be, right? It's going to end up being our outer squared minus our inner squared. Do we get that much so far? You
Yeah,
understand why that is? Okay. So now I need to come up with an expression for what our outer is, but it needs to be in terms of x. Okay? So what I know, right, is I know the distance from here to here, right? This much is what?
Would that be square root of x minus 3 or no?
It's plus 3. It's plus 3.
Oh, it's plus 3.
Okay, because good. Yeah, so the point here, right? This point here, this y coordinate, right? Which measures the distance from here to here, right? That is equal to the square root of x. But then from here to here, that is 3. I know it says negative 3 on the bottom, but it's 3, right? Okay.
Wouldn't it be like square root of x minus and then parentheses,
Minus negative 3, you mean?
Yeah, and then I'll make it plus 3. That would work too, right?
It would, but I always warn students, like, don't start relying on equations to be like plus minus what. You have to look at stuff. Like, you have to graph this and see what's going on, because you're going to get different intersection points, like such as we saw with Patty here, right? You see here, like, things are intersecting at weird places, and I'm like, okay, well, it's this one minus this one, or you know, not this one. This was another one, right? It was like, oh, I have to do it for this function for up to here, but then I have to do it for this function from here on. You really want to graph these, just to like kind of get a eyeball of it.
So even though if it's negative 3, just put like plus 3, like minus that.
Well, no, it's plus it, right? Because I want you to think about, you know, intuitively, what is this distance here, Josue, right? This distance right here is the square root of x. This distance is 3. So the total distance is the square root of x plus 3.
Okay.
Good? Okay, that's our outer. What's our inner then?
3.
Good. Our inner is always 3, right? Cool. Awesome. Okay, so this is always 3, right? Our inner is equal to 3.
Nice.
Now, we just do our integral, right? And we're going from where to where in terms of x?
Oh, 1 to 4.
Good, 1 to 4. Nice. So 1 to 4, this squared, so that's the square root of x plus 3 squared minus 3 squared, right? dx. Okay? I trust you can do this integral. I mean, what it comes out to, right? Yeah, you know how to do integrals. But this just becomes x plus 6 squared of x, and then it's plus 3 squared minus 3 squared, so these will go away. And so then you're just doing this integral and this integral. Totally easy. Cool? All right, let's see. Doing shells. I fucking hate shells. I don't really like shells. I don't want to do them. I don't like them. I don't like shells. I really don't want to do shells. Okay. Ugh. I think is it 2 pi r times h? Is that what it is? Let me. Sorry, I gotta Google it because I just use washers for everything. What's it? Shell method. I think it's like you build a bunch of cylinders.
It does revolve around like the y-axis. Yeah.
Uh-huh. 2 pi. Okay, wait. Excuse me? What the fuck? Wait, which axis are we rotating around? Rotating around the y-axis. Uh-huh, I agree with that. Okay. Oh, wait, no. This is them rotating around the x-axis. Dude, this graph is garbage, dude. What the hell? Okay. Yeah, that's where's this shell method that they speak of? I don't like shells. Okay. The shell method is 2 pi r times h. Okay. Yeah, so it's the it's like the surface area of a cylinder is what it is. Do you know that, like 2 pi r h?
Yeah.
Okay, cool. All right. I think it's dumb that they make you do it, but whatever. We'll do it. Okay, so this is a horizontal axis of revolution, right? So that's going to be dy. Okay. Okay, so volume is equal to 2 pi integral from here to here. Okay. Oh, this is weird, bro. This one has to get set up into 2, actually, doesn't it?
That's the part where I'm confused. Is separating them both.
Yeah,
And
you
then,
gotta.
you gotta,
Dude,
like,
this is
add 'em.
why. Oh, it's so garbage, dude. Okay, because look, because here's what happens. Okay, the height of my cylinder, like when I build my cylinder, is going to be constant as we go from here up to here, right?
Mhm.
The second I get to here, now my height starts changing, right?
Mhm.
So I'm gonna break this up from because this is dy, right? Yeah, dy, right? So the first one is going from 0 up to here, which is 1, right? Because when x is equal to 1, y is equal to 1. Does that make sense? Here, let me just draw this out again. It's 'cause, I mean, this just sucks. I hate that they make you do this. Like, what? There, can I get that? Yes, grab that. Awesome. Cool, love it. And then let's draw a black line for you here. Okay. All right. And then, yeah, let's get rid of this R outer, R inner, because we're not dealing with that anymore. Okay. And then this is here at y equal to square root of x. Okay. All right. So what we're doing is we're building a bunch of cylinders. Let me make the cylinders pink. Let's make the cylinders pink. Okay. And they're going to look like this. Well, let's see how good I can make my 3D drawings these days. Yes. Okay. Yeah, it looks to me like this. Okay, where? Okay. And let's make this also pink. This right here, this distance right here, is going to be the height. Okay, do you see how this is the height of our cylinder?
Yeah.
Okay. And then this is going to be our radius. Let me pick it out. This is what do I want to use for my radius color? Let's use blue. Okay. Let's make it a dashed line. Okay, so this right here is going to be my radius, okay? So the surface area of this part, right, is going to be 2 pi RH, right? 2 pi R times H, okay?
Mm-hmm.
And what I'm doing is I'm making these cylinders have bigger and bigger radii. So at the beginning, my cylinders don't have very much radius, and they're right here, okay? And then the radii of my cylinders start to increase, okay? And as they increase, right, I get more and more surface area of that cylinder being added. And that's why it's like a shell, because you're adding, it's like you're wrapping a piece of toilet paper a bunch of times, okay? You know, as you wrap the toilet paper more and more and more, the toilet paper starts expanding outwards.
Mm-hmm.
So if you take that surface area and you multiply by like how many layers of toilet paper you're doing, which in this case, that's what the DR term is, which in this case they're calling it dy. That's what this is. That's adding up like the thickness of these cylinders that you keep making, okay? The issue is that, so the height is constant up to this point, up to when the R is going to be equal to 4. Because when this distance is 1 and the total radius is 4, now my height starts changing as we go further and further out. Okay. Now the height of my cylinder starts changing. Okay. So we're going to evaluate this from R is equal to 3, right? Because that's the starting radius of my toilet paper. to r is equal to 4. Do you understand that? Yeah? No? It is complicated. I hate shells so much.
Oh, did you add a? Oh wait, hold on.
So this is my starting like roll of toilet paper, right?
Just 3, right?
Which has a radius of 3. Okay?
Mhm.
And I'm going out to a toilet paper roll that eventually has a radius of 4. Okay?
Okay.
And that entire time, right? My 2 pi RH, right? My radius is just going to be whatever the y coordinate is, right? That's just y, right? And then the height is a constant 3. Right? So this is sorry, my radius is y plus 3. The radius of, so the radius is toilet paper roll, right? Starts at, I see what's actually happening here. One sec.
Mhm.
Oh man. One sec. We're going from 3 to 4. Yo, thanks for the follow, dude. I hate shells. I hate shells. No, I really don't like shells. I don't like shells. I don't like shells.
No, God, please.
Okay.
Semifinal.
Dude, why? Why are they causing you so much pain? Okay, one sec. I'm gonna get this. All right. It's the radius. The radius is. Okay, we're just gonna say it's yeah, we're just gonna say it's y. Yeah, y is going from 3 to 4. Cool. That's the radius. Okay. And then the height is a constant 3, right? Okay. And then this is going to be dy. Good so far? So,
This is Y.
yeah. Radius, right?
Mhm.
The radius is like the y coordinate. Well, but we're going from 3 to 4. The other way to do this, here, I think this is the proper way they want you to do it. Sorry. I think they want you to say going from 0 to 1. And then it's y plus 3 times h dy. Does that make more sense? I think that makes more sense. Like, so your radius, right, is whatever the y value is, plus 1, plus 3. And then that's
okay,
going
yeah.
from 0 to 1. That makes more sense, right? Okay, cool. Yeah.
Yeah.
All right. And that's going up to 1. All right. And then look, the height is just always 3. That's constant, right? This height here is always 3 as long as we're going up to 1. Okay? However, now we got to deal with this. Cuz now the height changes. As this height is going to change, which is super ugly. Okay. So v is equal to 2 pi. Now we go from 1 to what? What's our y value here when we intersect up here?
Well, now you gotta figure out the point there, right?
Yeah, good. So y is equal to the square root of x, and right, x is equal to 4.
Low to the power of 2.
Good. Yeah, so we're going to go from 1 to 2, okay? All right.
Oh.
Let's keep grooving, dude. Okay, so then this is going to be, right, y plus 3, right? It's whatever my y value is, okay? As we're going out, okay? But now the height is going to change, right? So this is where, like, you have to kind of draw, like, a mock picture of what's going to happen, okay? So let's say we're here, okay? I agree that this distance, right, that is y, and this whole thing is 3. That's why the whole radius is y plus 3, okay? But I want to know what this is, what this h is, okay? All right. I know that going all the way from here to here is how much distance?
Where to work?
Yeah, good. So going to here, right?
Right. Okay.
That's 4, okay? But I want this, okay? I also know, right, that going from here to here, right, that's the x-coordinate of this function, okay? Which, if y is equal to x, what is the x-coordinate equal to?
Y squared.
Y squared. Good. Do you understand how this is y squared? This distance from here to here is y squared? Because, here, right? As we travel along this line, Josue, right? As we travel along this line, the x-coordinate of the point on the line, right, describes this distance. The x-coordinate I could write as just x, but x is also equal to y squared. That's the relationship between the x-coordinate of this function and what y is equal to, right? So describing the x-coordinate of this function is the same thing as saying, okay, but what is y squared? That's why, for instance, right, when I'm here, right, and the x distance is 4, right, that's the same thing as the x distance is equal to y squared, because here y is equal to 2. You see how, like, if I put y is equal to 2, I get, okay, cool, I'm at x equals 4, right? If I put in, get rid of this. If I put in, what is it? Like, x is equal to 1, right? Y is equal to 1. Okay. So this is y squared, but I want this distance, and I know this whole distance is 4. So what is the height equal to?
4 minus y squared.
Good. Yes. So the height is equal to 4 minus y squared. That's why the height is now a function of y. Here it was not, right? Because here the height was always just 3.
The constant, right?
Good. Yes. Okay. So this is y plus 3 times 4 minus y squared. And then it's just dy. And then you're done. Yeah.
You
Dude,
add both of the integrals, right?
Yeah, so that's, and then you have to add them. You have to add them together, right? So it's technically this one plus this one. Okay.
Okay. All right. Yeah.
Yeah.
Okay.
Yeah. They suck. Oh, and notice how they say do not evaluate. Yeah, bro. Because evaluating this integral would like really suck. Like it would. It's terrible. Don't do it. This one is much nicer. This is so pretty. Washers forever, dude. I do not like shells. Shells are bad. No. Anyways, okay, cool. All right, that makes more sense to you, Josue. Yeah. Yeah.
Yeah.
Here, I'll send it all to you so you can have it. Yeah. Nice.
Yeah.
Good shit, dude. Awesome. I appreciate that question because, man, I have not done shells in forever, and I really don't like shells. I don't know why they teach. Why do they teach it to you? Why do they teach you shells? Everything can be done with washers.
Oh, I think the reason they do that is because the class is a weed out class. So.
Oh, yes. I mean, okay, so this speaks a lot to, even a lot of things in math. People are like, why am I learning this? And yeah, it is because it's a weed out. They're trying to like see who really wants to learn it. Yeah. It's who's going to go out and find help. See, what you just did, Josue, is a beautiful example of what you need to do as an adult when you get a job. Because you're going to get stuff where you're like, I have no clue how to do this. And you have to have the skills to be able to find resources to solve it. Yeah. Yeah.
That makes sense.
Peachy says, wouldn't that one just turn into a relatively safe polynomial, third degree? I was just, yes, you're right. No. Actually, yeah, so Peachy is right. Yeah, this actually isn't the worst integral. I take that back. Because yes, you just foil this out and it's not that bad. Yeah, thank you, Peachy. You're so right. Yeah, it's just a third degree. Actually, so maybe this one is prettier. But look how much of a fucking bitch that was to set up. No. This one, super easy. Super easy for me to describe this. This one, bro, I feel like I'm doing the whole thing. That that scene from like It's Always Sunny, dude? What is it? It's always sunny the conspiracy board, dude. I feel like this guy, dude. I feel like I'm like cracked out, like trying to describe, well, the height does this and this does this. No. No. Okay, nice. Good shit. Let's help out Ethan, and then I got Taco Cat. Yeah. Nice. Sweet. All right. What's up, Ethan? Yeah, let's help you out, dog. And then Taco, we got you. Taco, let me teach you something new, dude. We've been doing like silly stuff with chemistry for a while. Okay, but what's the question here, Ethan? What this is a function. I understand it's a function. What do you want me to do with this function?
It's like a derivative.
Oh, they want you to find the derivative of it?
They want you to find the derivative of h, y, and all of that stuff.
Okay.
Whatever
Well,
that is.
Find h prime of y. That's not bad. Do you know how to find a derivative? Yeah, this means the first derivative. This is called first derivative. The other way they write this is they'd write this as dh dy. That's what they would say. It's calculus.
Yeah, I just do not know how to find the derivative.
Okay. So when you have simple things that are just exponents, the proper name for this is it's called a polynomial. Poly means many, nomial means term, so it's like many terms. Yeah. We do what's called the power
Isn't
rule.
that a trinomial instead?
It's a quad. It's a quadrinomial. Like 1, 2, 3, 4. It's 4 terms.
Okay.
Tetranomial? I don't know. They use like different prefixes for stuff. Okay. The power rule says if I have x to the n, then taking a derivative turns this into nx to the n minus 1. That's the fancy math language for it. Can you understand this, Ethan? Like what this like if someone gave you this math rule here, would that make sense to you, or does this look like gibberish?
No, it doesn't look too much like gibberish. I mean,
Oh, that's good. We like
I've
that.
learned lots of.
Yes, good job, dude.
Laws of
Okay.
Listen and talk here.
Okay. So if I have like x to the 5th, what would this become?
5x to the negative 5.
No, not to negative 5. Nope.
No.
What?
So look, the number comes down. You were good doing that, but in the 5x. Okay, but then what does the exponent become?
4, because it's
4.
subtracting by 1.
Yeah, it's 4. You drop it by 1. That's what you do. Okay.
Okay.
So what if I have like 40x to the 3rd? What does that become?
Wait, you want me to do like put it back in the other sense of form?
No, I want you to derive it. Derive 40x cubed.
What this is fun.
Same
Is it
rule.
gonna be like 3 times 40x to the squared or something?
Yes, dude. Nice. Good job, dude.
Yes!
Good job, dude.
Hey, come on, baby! Come on! Yes!
That's gonna be 120x squared though. 120x squared is what it comes out to be.
Well, yeah. I mean, they are like terms, so I can understand.
Yes, yeah, good. Okay, all right. So let's try to do this one.
So
What's up,
you
dude?
know, it's fun. That's what you learn in calculus, right? Like half of the semester, you learn that in calculus.
I think you learn this within the first week of calculus. What they actually teach you to do, which like really sucks, is they make you learn the limit definition of a derivative first, which I have a video on my TikTok. Where is it? There you go. If you guys want to learn about the limit definition of a derivative,
Now, I know you're probably used to seeing
this is
written
the
out with
form that you're
staring
supposed to
math
use,
hieroglyphics, but if we look at it piece by piece, it's actually pretty.
and it has to
Oh my
do
God,
with like. You should watch this. It's a cool video I made about like how the limit definition works. But yeah, it's basically if you have like a point and another point, and then you calculate the slope in between the points, and then you bring the points closer to each other, you're gonna get like what a derivative is. And they make you learn this first when they're teaching you like how to do derivatives, and then they just teach you the power rule. So I don't know. I don't know why they teach you the hard way first. It's good for character or something. I don't know, character development. But yeah. But that's where it comes from, all right? Then they just teach you there's a shortcut called the power rule, and this is the power rule.
It looks like I'm already understanding it.
Yeah, I'm glad. Yeah, that's dope, dude.
Nice.
Okay, so how do I do this one,
I'm
though?
not-
What's up? What's the answer? Yeah, no, calculus isn't that bad. They make it like seem like it's all scary, but it's not.
No.
It's actually pretty. It's not that bad. pretty cool.
Is this calculus 1? Is this calculus 1?
This is calculus 1. Yes. First semester calculus.
Wait, I don't even want to know what. I don't even want to imagine what 2 and 3 are like.
Well, calculus semester 2 is this. This is second semester calculus. What I was literally just doing with Josue. That's second semester calculus. Yeah.
There's no way that's all. Calculus is all of that, right? There's no
Maybe
way.
it's like close to third. No, but I think it's second semester. Okay. All right. What's up? Let's try to do this one, Ethan, so I can get the Taco Cats question because I gotta run to go teach another kid soon.
So wait, hold on. What's this HY thing doing there? What's the purpose of that?
It's a function. H of y means I plug in a y, I get an h. That's what it is. Like big box. There's a box here, right? H of y. Okay. You put in a y, it spits out an h. That's how it works. Yeah. Functions are like microwaves. They change things. Like you give it an input, it gives you an output. Okay. How do I do this one, Ethan, though? How do I do the derivative?
All right, so I think I can tell how to do this.
Mm-hmm.
But when it, wait, no. Okay, I think I know how to do it. So it's like, maybe take the y and to the -4 power. I think that becomes 4 times y to the
No,
negative 5, right?
-4. -4 times. -4.
Oh,
The number up here is negative.
Yes, I know. But I thought we always converted it to positive. For some
No. Don't consider it a positive. No. It's whatever the number is. So it's -4y to the what?
All right, and then to -5.
Nice.
Okay. What about this part?
Negative. Hold on. -3 times 9, which is just positive 27, right? Like,
Yes,
plus
good.
27.
-3 times -9 is positive 27. Good.
Y -4.
Good.
Nice.
What next one?
Hold on. -2 times 8, which is -16.
Good. -16.
Y to the negative, or to the negative cubed, as you would say.
-3. Very good. Okay. What about this last one? The last one's kind of scary.
It's not scary. It's literally just the same.
What is it?
Isn't it just 12 then? Or
No.
okay then.
Not just 12.
Hold on. But let me guess. You gotta add the imaginary y there.
The imaginary x, right? So technically there's an x to the 0 here. So do you remember anything to the 0 power is just 1?
Yeah. That's
So really
about
there's a
in the
there's a 1 here. There's a 1 here, right? 12 times 1 is just 12. But 1 is also the same thing as x to the 0.
Yeah, but I don't get what you're trying to say. It's just
Okay.
12.
Okay, but no, what's the rule though, right? Remember how I take this, I multiply it by this, and then I drop the power?
Okay then.
What's 12 times 0?
Oh, it's literally just 0.
That's dope.
Yes. That's why this becomes 0. Yeah?
Wait, that's not too bad.
Yeah, it's not too bad.
Then you try to solve that, right?
No, you don't solve it. This is just a derivative. You just calculated the derivative. That's all you did. But this is an important concept. Anytime you have a number that's a constant, so a number that does not have the variable that you're looking for. Sorry, and this shouldn't have been x to the 0. Sorry, this should have been y to the 0. My bad. Because everything's a function of y, but it's the same shit. Whatever. Okay.
All right.
But yeah,
man,
anytime
this
you have a
is kinda-
constant, the derivative of that is 0.
This is calculus 1. Maybe I could just actually do it for once.
I think you could, dude. Yeah.
Well, I thought, I initially thought calculus was scary.
No, calculus is not scary. No, calculus is dope. Calculus is
Alright.
actually like one of my favorite math classes because there's a story to calculus. Like there's a progression that makes sense. When you take things like pre-calc or geometry, it's kind of random, honestly, the topics. They don't make sense. Like in pre-calc especially. Because pre-calc, you'll go from, trig functions to graphing conic sections to then, I don't know, doing whatever, rationalizing roots or stuff. Like none of this stuff seems connected. Because what you're doing is you're building up the toolbox of tricks, as I would say. I know Zach doesn't like me calling it math tricks. But you're building up a toolbox of tricks in math so that when you get to calculus, you have all the necessary tools to like complete the journey. Because calculus builds on itself. Like everything you learn is related to the thing beforehand. And there's a cool path that you start seeing. Like you learn like limits and then you're like, oh cool, I can use limits to then calculate derivatives. And like, oh good, cool. Now I can use derivatives to find extrema, and then I can use extrema to like maximize and minimize, and then from that I can do related rates. Like everything builds on itself. You get to integrals, you learn about Riemann sums first, then you learn about integration, and then you learn about, oh, I can do volume of integration, and now I can take integration and write it as a series, and now series have convergence, and like everything builds on itself. It's a very cool class.
No.
Yeah.
Honestly,
It's like the
I feel
penultimate
I
math
should take
class.
calculus. But
What's
I
up?
feel like I should take calculus 3.
You should take calculus. I tell everyone they should take calculus, and
I mean,
if you have problems with it, like come on the stream here. I'll teach you. Calculus is like one of my strongest subjects that I teach. I teach a lot of calculus.
I just thought to go like, should I take calculus number 3 then?
You should start taking calculus 1. Like don't jump ahead too much. Don't jump
What
ahead
does
too much.
calculus 3 even do? Does it use calculus 1 and 2?
It does, yes, but you have to take 1 and 2 first. Calculus 3 is like vector calc. It's multivariable and it's like 3D stuff. It's a little confusing.
All right.
Okay.
It's
Cool.
just I think I strongly on some derivatives, but what about anti-derivatives?
That's integration. That's for another time. Yes.
All right, but
That's calculus 2. That's what I was doing earlier. I was doing earlier with Josue. I was doing integration.
all right. Well, yeah. Honestly, I wonder who invented calculus. You know,
Newton.
Isaac Newton himself again.
Yeah, he created calculus because he needed math to do physics. Is what he needed. Newton plus Leibniz.
Physics.
Yeah, it's never just one dude. You're right, Peach. Yeah, it's like people say like Einstein created whatever, like relativity. Like he put together a lot of other people's ideas in a cohesive manner, packaged it nicely, and it's like created it. I think Newton did have a bigger influence though on calculus than Einstein did on relativity though. Einstein gets all the credit, but you know.
Is there such thing called AP calculus?
Yes, it's 100% a thing called AP calculus. Yeah, I teach it a lot.
Okay, so what does AP stand for? I don't.
Advanced
get that.
placement.
I always hear about.
Advanced placement. Advanced placement means that you take an exam, and if you do well in the exam, they give you college credit, which is great.
Oh,
We love
come
college credit.
on. Really?
Yeah. I don't think
Where
you
you
have
gonna-
AP. You're in Belize, so I don't think they have AP exams out there. But they'll have what's called IB, like International Baccalaureate. So that's another thing that works.
Ivy? What?
IB.
What's
Ask your high school counselor or whatever. Be like, yo, do we have any like college credit math classes? Taco Cat, where you at? Let's learn some chem before I gotta go.
All right. Well, I'll ask more calculus questions then.
Nice.
Yes, please do. And if you want a textbook like what Teacup does, you know, I can give you a textbook for you to go through questions. It's super easy. Yeah.
All right. Well, give me the textbook then.
Yeah, you want the
Because
textbook? Here, I'll give it to you
I'm
right now,
on-
dude.
Okay. Also, Tactical. I actually think
There you go.
I feel like I'm doing too much for my semester.
No, it's okay. You can handle it, bro. What's up, monkey?
No. Tactical. No. I mean like my actual school semester. You want to know what I'm doing?
What are you doing, dog?
Like for my environmental science class.
Oh, environmental
I'm
science is easy,
deciding
bro.
to do,
Environmental science is easy. What?
Like, sure hope so.
It's just like, how are the frogs
Okay.
doing?
Hey, I'm not done. Let me
Okay,
talk.
but Ethan, I gotta run. So let me, yeah, you DM me outside. Let me help Monkey with this question. You can DM me about your class stuff later. I gotta get everyone's questions before I gotta go to another place. Okay. All right, Monkey, where are you at? Yes. Oh, hi, Monkey. Okay, cool. All right, we're gonna balance equations here, Monkey. Chemical equations. Do you remember how to balance this? These are fun. We love these. This is actually gonna be a complicated one. I'm pretty sure. Yeah, let's see what we get here. I think this is going to be a fun one. What's our first step, Taco? What do I do? I know you're there, Taco. Where you at, Taco? All right. He says, all right. Okay. Yeah. What do we do? What do we do? We got to create the table first. Yes, very good. Yes. So what we're going to do is we're going to create a table of what the different elements are on both sides. And they're the same ones are going to appear on both sides, okay? So we have, for instance, I have sodium, I have hydrogen, I have carbon, and I have oxygen, okay? And that same thing is going to be over here as well, okay? What do I want to do next? What's the next step here? Dun, 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 dun.
Where you
Like,
going?
wait, dude. Monkey.
Where you
Taco.
going?
Sodium is 1. Very good. Yes. Okay, cool. Right. There's 1 sodium. There's 1 hydrogen. How many carbons? Oxygen is 3. Good. And yeah, 1 carbon. Yeah, good, good. You got them all. Okay, cool. This side gets a little bit more complicated, right? I got 2 over here. I got 1. No, how many carbons do I have, right? What's going on here? How many carbons do I have? Carbon is 2. Good, yeah. So I have 1 here and 1 here. So there's 2 here. H is 2. Yes, H is 2. And then oxygen. Oxygen's a real bitch. Oxygen is 6, yeah, because I got 3 plus 1 plus 2. Okay, we got 6. All right. General way to like attack these is to kind of go for like what's the most complicated thing and make sure that balances first. Okay? What thing looks the most complicated here? Like out of all these things. What thing shows up in all the complicated stuff? I think that, like, this is the most complicated, and this is the most complicated. Like, water and carbon dioxide are pretty chill. And what I see in these two things is that sodium is the one that's in it, right? So let's try to balance the sodium first. Good. Exactly, yeah. So to balance the 2 with the sodium, I would put a 2 over here. So let's do that. Let's get rid of this. Let's put a 2. That's going to change everything, though, right? Because now I'm going to have 2 hydrogens. I'm going to have 2 carbons. How many oxygens am I going to have? Yeah, we assume everything else is 1 for now. How many oxygens do I have, Taco? Once I put a 2 in front of here. We got 6. Nice. Very good. Okay, cool. All right, so now it's a 6. So this is cool. So oxygen's actually balanced. That's nice. Carbon's balanced. Oh, is everything just balanced that easily? Oh, that's super dope, dude. Wait, what? Okay, cool. Oh, that's easy then. Look at this. It actually just all balances, really? Just 2, 1, 1, 1? Oh, this was dumb easy. Okay, whatever. Good job, Monkey. I'll give you a harder one next time. Yeah, I wanted one with like fractions and stuff, but that's totally cool. We'll do this one. This one's okay. Yeah, easy. Let's go. GG's. Okay, awesome. All right, thank you everyone for coming to Office Hours. Had a great time helping all you guys out. W stream, yeah, great time, guys. For those that are new watching on the Twitch, there's our Discord. You can join up, find out about all the cool stuff we do. We stream 3 times a week. There's our schedule. If you ever want to get help with math or science homework, that's our schedule. If you want to know some other really awesome math streamers who stream on Twitch, they're all the math streamers. They're very cool as well. Our next stream is going to be tomorrow. That'll be at 5 p.m. Pacific, 7 p.m. Central, 6 p.m. Eastern. And then on Thursday, we're going to do a very special Golden Hour AMA podcast. So that's where I bring on a guest to have you guys ask whatever. Her name is Jess, and she's a therapist. So she's going to be answering any questions you guys want about therapy. You get free therapy. Like, congrats. I'm gonna make the post later today so that you can submit your questions. I'm also gonna allow you to submit questions anonymously if you want to like ask a question that you don't want other people to know that you asked. Because I get it. It's a therapist. You don't want to exactly let everyone else know that, I don't know, you have like an unhealthy relationship with Doritos or something. But for any other like questions you want to ask and you don't mind other people knowing you're asking it, please do. That'll make sure that we can give you credit and so that you get entered into the giveaway. But if you have other sensitive questions that you don't want people to know are coming from you, I will also provide like an anonymous link that you can do that. Yeah. What if I like men? Cool. Yeah, that's a perfectly fine question as well. You can ask that. I don't care. It's an AMA. You can ask whatever you want. Anyways. Yeah, Cap, he says. Yeah. Okay, cool. All right, let's see. Who else is streaming today? Is anyone live? Or is no one else streaming at this? Let's see. Who else is live today? Suburban Lion. I don't know who Suburban Lion is. I'm not following them. Okay. You know what? Go say hi to my friend Paleontologizing. He's a paleontologist. He's very cool. He learns about like dinosaurs and stuff. Go say hi to him. We're gonna raid his channel. And I will see you guys tomorrow for the next stream with Office Hours. Have a wonderful rest of your Tuesday. I will see you guys tomorrow. Peace out.